Hello everyone. We are going to see today one important aspect in theory of computation called push down automata. So for that purpose we need to first understand the definition of a context free grammar. We define context free grammar as a grammar having, say, production of this form: A gives alpha, where this A belongs to variable set and this alpha belongs to variables and combination of variables along with the terminals. So for such kind of particular grammar we can define a machine which can be accepting rather language which is a context free language. So let us try to see first how exactly this works. So this push down automata considers a tape. There would be some control unit available. This tape would be divided into some set of inputs. This will contain the string that is available with your language. Say for example some language is given which is context free language, fine, and there will be some particular condition given for how the string should be as a part of this L. Let us say we have been given a tape. This is control unit that we have, control unit. Then one additional memory that we are going to use here in push down automata called as push down stack. Correct. So there would be different elements possibly into this stack. There would be a read head rather available with this control unit, which will read input, then which will process here, will change probably the state, and some change probably might be there into this stack. So accordingly, let us take a sample case. So if first of all let me define this push down automata. This push down automata would be defined by, say, tuples, 7 tuples. So q sigma delta, q sigma delta, tau, q0, then r, and then f. So these would be 7 tuples where q denotes a finite set of states. Sigma would be set of input symbols. This tau would be set of stack symbols. This q0 would be initial state belonging to capital Q. This r would be a special top of the stack symbol, probably or definitely from this tau, which is a set of stack symbols. F is set of finite states, which would be kind of subset for capital Q that you have, or set of states. This transition function will be defined using combinations of few of these things. So let us first try to understand how this would be designed, and accordingly we will define definition for this delta. So we will take an example where we will have a language defined as, for example, a raised to n, b raised to n, n greater than equal to 1. Now to define this we definitely need to make use of control unit, which will be having transitions defined through delta, which will be having the states from capital Q. Inputs string which would be available from that language would be formed using sigma. Elements on this would be defined through this tau. So let us take an example and work out this. So as we have been given language as a raised to n, b raised to n. So for that purpose I will assume one string as, say for example, possible strings which can be there as a part of this L are AB, AABB, AAA, BBB, and so on. So it could be a raised to 5, b raised to 5, comma, a raised to n, b raised to n, where we are controlling here occurrences of a's and b's to be equal. Fine. So for this purpose let us try to take a sample case as this. Suppose our tape has this string A, B, B, B. Fine. And as a definition of PDA that we saw, we assumed that there is a special top of the stack symbol called R. So we will define few set of elements here for this tau rather, which is set of stack symbols. Let me define that this stack is kind of a stack for this stack would be of dishes, different colors. So let us describe those colors as red, green, blue, and so on. So for a while I am assuming this scenario, in this case RGB. So this R would be always special symbol which would be top of the stack at the initial, with the initial configuration that we have. We'll assume that our PDA would be always in initial state called Q0. Now, if I have to design a push down automata which works with this particular language, we'll start with this. So, if my PDA is in initial state called Q0, so always as a definition of given language, I can see that my string is always going to start with A. So, I always would be getting A onto the tape, and at the same time I am going to see what is there as on the top of the stack. So, in this case with the initial configuration I have R. So, I will take this scenario as a first instance while trying to design an definition for a PDA. Now, as the language given to us is A raised to n, B raised to n, whenever I get A, I need to find out whether appropriate B's are there or not. So, number of B's and number of A's should be same. So, what I will do, I will try to see that if I can design my logic in such a way that if A is found, I will put something onto the stack. For each occurrence of A, for example, when A is found, let me put, say I am writing B, or I am putting blue plate onto the stack. I again got A, I will put blue plate. I got again A, I will put blue plate. Whenever I get B, then what I will do is, now I have to pop all of these, because for 3 A's I pushed 3 blue plates. So, for each occurrence of B now, I am going to pop from the stack. So, for this B, I will pop this. For this B, I will pop this. For this B, I will pop this. Now, whenever my string ends, I am representing that string using epsilon. So, this is the scenario, and we will define afterwards like how the string should be accepted. So, let us try to define this particular case. So, I have delta Q0 AR. So, as we said that for each occurrence of A, we are going to put blue plate onto the stack. So, now how will I write it? I will make change in the state as Q1, fine. Then I got A, I got R, so I will get BR, because this was earlier top, now I have top, at the top is B. So, I got this scenario. Now, when this was read, this read head will move to next symbol. Now, I got A, my PDA is in state Q1, I got again A, and then on the top of the stack, I can see that there is a blue plate. So, ultimately, as we decided earlier that whenever we see an A onto the tape, we are going to push a blue plate onto the stack. So, this will result to Q1 B B. Make note here that I am not changing the state, because I may be getting many number of occurrences of A's at later stage. So, that is why I am assuming that this transition function would be executed recursively for each occurrence of A. Now, suppose I am getting this second A, I am pushing one blue. So, I did that blue. I got this now third, I got A, I will execute same transition function. So, I got Q1 AB again scenario. So, I am going to push one more B. So, I got now 3 B's and all A's are covered. Now, the next input symbol that I can see on the tape is B. If I see that, I will check in which state I was. So, I was in Q1. So, input that I got onto the tape is B, and at the top I can see that there is a blue plate. Now, as we discussed earlier, for each occurrence of B, whatever is pushed, we are going to pop it. So, the popping operation would be represented as, now I will write Q2 epsilon. Now, when I do this, ultimately what I am doing here, whenever I write epsilon, actually it is trying to tell me that whatever the blue plate available at the top of the stack, I am going to remove it from the stack. So, for first B, I removed this. So, I got this removed. Now, this will be moving to next input symbol. Now, I am currently in Q2, which is one state. I got B, and at the top again I got B. So, I can write it as Q2 epsilon. So, the way that we use this function for pushing respective elements, respective plates on the stack, same way I am going to use this function for popping elements from the stack. Now, for next B, I popped this because of application of this. Again, I got another B. I was in same state, so Q2 B and that B. Again, I am going to pop this. So, everything is popped now. Now, it reached to this place. So, now as my string is over, so I will write Q2, string is over, and now remaining element onto the stack is R. So we can have this definition of this transition function defined or accepting this string by entering into final state. So we will write it as QFR. So that's how we can design this transition function. So if you see, these 5 definitions of transition function would be applicable for any kind of definition. So let me add one more string here. For example, I am taking 5 A's and 5 B's. So we will see whether it is applied effectively or not. So 1, 2, 3, 4, 5 A's, and now 1, 2, 3, 4, 5 B's. So let us try applying this. So initially we are in Q0, we got A, and at the top of the stack we have R. So when we apply Q0 AR, it is entering into Q1. So this blue would be pushed into the stack. Now it is pointing to next A, again Q1 AB. So for each occurrence of A now, I am going to push blue plate. So this is moving to next. Again I got Q1 AB. So I will push one more element. So this will move to next. Again Q1 AB, I will push one more blue plate. So now I got this A. Q1 AB, again I am going to push blue plate. So now I got B and then B. So Q1 BB. Now I am applying this transition function. So now I have to, as we decided, for each occurrence of B we are going to pop. So this is popped. Now again we are here. Our program is PDA is entered into Q2. So Q2 BB again. So it would be pop. So this would be popped. It will move to next. Again Q2 BB. This would be popped. This will move to next. Then again Q2 BB. This will be popped. It will move to next. Q2 BB. Again after application of this would be popped. It will reach here. Now we got the same scenario, Q2 epsilon R. So it will enter into QF. Now you may say, like, what are the example that we have taken here? We have always taken a valid string. Let us take an invalid string where number of A's are more than number of B's. So let me take 3 A's and 2 B's. Sorry. Epsilon, we have R. So delta Q0, we are initially in Q0, delta Q0 AR, it will apply this. So for this A, we got B, it is in Q1, so Q1 AB, so Q1 AB results to Q1 BB, it will be BB. Again next Q1 A, it is here, Q1 AB, it will push one more string. Now we got Q1 BB, so Q1 BB results to Q2 epsilon, so it will move to next by popping this. So we got Q2 BB. So this will be popped. Now it is moving to this. Now one can see over here that string is completed. There is epsilon, but still there is something onto the stack. Now we got the scenario as Q2 epsilon B, which is not declared by us here. So ultimately this results to non-acceptance or rejection. So for this example our PDA will not work, because we have designed this PDA for all possible strings which are part of this L. Now in this case I took more A's and less B's. So you can have another scenario as well where you have less A's and more B's. This would be epsilon. So again let us check. We are in Q0. Q0 AR. So this will give Q1 BR. It will move to next. We got Q1 AB, Q1 AB results to Q1 BB. Now we got Q1 BB, Q1 BB, which is popping this. So this will move to next. Q1 BB. Earlier we entered into Q2. So Q2 BB. So this would be Q2 epsilon. So this is popped. We got Q2 BR. Now one can see here we don't have any transition function defined with BR, B to be there and R to be at the top of the stack. So that's why it is again going to reject. So for all strings which are not part of this set, this will work out. Now using this example, we can define now definition of a transition function. So if you see here, when we wrote this, we said that there will be state taken here we are writing definition of delta. A state would be picked, input from tape would be taken, and we are going to see what is there as on the top of the stack. So after application of this, it will result to some state and definite modifications here. Now either it would be push, pop. So one can see here, it was push, this was pop. And here we have even seen that there is no change because we haven't popped anything from the stack. So there might be push, there might be pop, or there is no change. So we can represent it by this. Here, if we see this, this would be either empty, which one can see here. Okay, if it contains one element, one can see here. If it contains two elements, that can even be seen here. So that's how you define transition function for PDA. And this is how you are going to design a Turing, the push down automata. Fine, thank you.